Picture this. You're just going about your day, doing your normal routine. Maybe you're checking your phone, pouring that first cup of coffee, or, complaining about morning traffic, when suddenly, without any warning whatsoever, our star just completely ceases to exist. And I don't mean it explodes into a supernova or slowly burns out. I mean it vanishes, literally deleted from the universe. Welcome to today's Explainer. We're diving straight into a fascinating, slightly terrifying look at the science of the unthinkable. We're going to break down exactly what would happen to Earth, to humanity, and to our entire solar system if the sun were just gone.
Okay, so what if the sun simply vanished? Well, honestly, the most mind-bending part of this whole scenario is how it begins. For those first few minutes after the sun is wiped from reality, you wouldn't even know it happened. You'd just be walking around, enjoying the daylight, totally oblivious to the fact that the gravitational anchor of our solar system is just missing. Humanity would actually have exactly 8 minutes and 20 seconds of glorious, ignorant bliss before we even noticed a single thing was wrong.
Section 1. The 8-minute illusion.
So why do we get this weird 8-minute grace period? It all comes down to the cosmic speed limit, 186,000 miles per second. That's the speed of light. Now, the sun sits roughly 93 million miles away from Earth. That is a gulf so unimaginably huge that even at that blazing speed of 186,000 miles per second, which, by the way, is fast enough to lap the Earth 7 times in a single second, it still takes a photon of light over 8 minutes to cross that distance. That means every gorgeous sunrise you've ever watched, every ray of warmth you've ever felt on your skin is actually an 8-minute-old echo. So when the sun vanishes, its final beams of light are still in transit, painting this massive illusion in our sky of a star that simply isn't there anymore.
Section 2. How the sun works.
Right before we completely turn out the lights on this thought experiment, let's take a quick flashback to understand the absolute powerhouse keeping us alive. Our star is essentially a gigantic, ongoing fusion reactor. Every single second, the sun converts a staggering 600 million tons of hydrogen into helium. And it's doing this at a core temperature of 27 million degrees Fahrenheit. The energy released from this is so incomprehensibly massive that even the tiny, tiny fraction that happens to hit our little blue rock is enough to power almost all life on Earth.
But how does a star actually pull that off? Normally, 2 hydrogen protons desperately want to push away from each other because of their positive electromagnetic charge. It's exactly like trying to push the same ends of 2 magnets together. But the sun's gravity is so immense, so crushing, that it forces these protons closer and closer until a totally different law of physics takes over, the strong nuclear force. This fundamental force is millions of times stronger than the electromagnetic repulsion, but the catch is, it only kicks in at incredibly microscopic distances.
So basically, gravity just bullies these protons together until, snap, the strong nuclear force locks them into a new bond. Boom, helium is formed, and these massive, massive amounts of energy are released. This is the engine, the exact sequence of nuclear fusion that warms our entire world.
Section 3. Einstein's curved space-time.
Now, here's where things get really fascinating. It isn't just light that takes 8 minutes to reach us. Gravity is bound by that exact same cosmic speed limit. If you contrast Sir Isaac Newton's ideas with Albert Einstein's, you see this massive shift in how we understand the sun's disappearance. In Newton's classic view, gravity was like an invisible tether, this instantaneous pulling force connecting the sun and the Earth. If he were right, the very second the sun vanished, Earth would instantly fly out of orbit, even while the sky was still bright. But Einstein's general relativity tells us a much wilder and much more accurate story. Einstein realized gravity isn't a pulling force at all. Instead, massive objects like the sun literally bend and stretch the fabric of space and time itself.
Think of it like walking on a giant globe. If you and a friend start miles apart at the equator and just walk straight north up the longitudinal lines, you're eventually going to crash into each other at the North Pole. You didn't feel some mysterious force pulling you together, you just followed straight lines on a curved surface. The sun curves the space around it, and Earth is just traveling in a straight line through that curved space. So when the sun vanishes, the unbending of that space ripples outward at the speed of light. Gravity, just like the light, takes 8 minutes and 20 seconds to get the memo that the sun is gone.
Section 4. The lights go out.
So, the clock ticks down. Those 8 minutes are up, and the illusion finally shatters. That gravitational wave washes over us, the last photons hit our retinas, and the lights go out. Literally. One moment it's daytime, the next it is absolute pitch black night. And it wouldn't just be the sun. Our moon would go instantly dark, right along with it. Remember, our moon produces absolutely no light of its own. Every phase we see is just reflected sunlight. Even Earth's shine, that dim glow on the dark part of a crescent moon caused by light bouncing off Earth, gone. The moon would be totally swallowed by the dark. The only natural light left anywhere in the sky would be the distant, piercing glow of other stars and the Milky Way, which would suddenly be visible with a terrifying, unprecedented clarity.
And physically? Man, at that exact moment, cut loose from the curved space-time of the sun, Earth just obeys Newton's first law of motion. Like a heavy ball swung on a string that suddenly snaps, our planet violently shoots off into the void of space in a straight line at roughly 67,000 miles per hour. We aren't orbiting anymore, we are drifting.
Section 5. The deep freeze. All right, let's break down how this disaster actually unfolds chronologically. Because, surprisingly, Earth wouldn't just freeze solid the second the lights went out. Space is a vacuum, meaning it's actually a pretty good insulator, so Earth would lose its heat slowly through thermal radiation. Within about a week, global average surface temperatures dropped to 0 degrees Fahrenheit. It's harsh, for sure, but surviving it isn't impossible if you have a seriously good winter coat. But look at the 1-year mark, negative 100 degrees Fahrenheit. And if we fast forward over millions of years, the surface is going to hit negative 400 degrees Fahrenheit, eventually balancing out only with the tiny bit of heat radiating from our planet's own radioactive core.
Down in our oceans, things get kinda ironic. The surface freezing over, that actually turns into a lifesaver for a very specific group of organisms. Since ice floats, that frozen top crust would act like a massive thermal blanket, trapping the liquid heat in the deep water below. So for hundreds of thousands of years, extremophile bacteria and tube worms hanging out around deep-sea geothermal vents wouldn't even realize the sun was gone. I mean, they already live in total darkness, powered entirely by Earth's internal heat. They'd happily survive our planet's apocalypse.
But up here on the surface? Oh, it gets so much worse. Once the temperature drops far enough, the very air we breathe will undergo a phase change. The atmosphere will literally freeze solid. Just try to imagine the visceral, terrifying reality of oxygen and nitrogen snowing from the sky, leaving Earth as nothing but an airless frozen ball.
So, what about us? Humanity? Well, no sunlight means zero photosynthesis. Period. Plants are done in weeks. Maybe some massive trees last a few decades on stored sugar, but a total food chain collapse is inevitable. Humans would have to get incredibly creative to buy some time. We'd probably retreat into deep ocean nuclear submarines. Or, interestingly enough, we might all flock to Iceland. Since Iceland already heats about 87% of its homes using geothermal energy, scientists theorize a fraction of humanity could cling to life there for a few centuries huddled around volcanic heat. But eventually, with absolutely no ability to grow food, starvation is a mathematical certainty.
Section 6. Rogue planets do exist.
Now, this whole explainer transitions from a crazy thought experiment right into stunning reality, because scientists actually discovered this happening out there. Using the Pan-STARRS telescope, they found a young super-Jupiter, a massive gas giant just drifting aimlessly through the interstellar void. No star to warm it, no star to orbit. It was either violently flung out of its solar system by chaotic gravity, or it literally formed entirely on its own in the middle of nowhere.
And honestly, that discovery is just a haunting, real-world mirror of what we've been talking about. Without the sun, Earth would become exactly this, a frozen, airless ball literally drifting through space. We would just join the ranks of these lonely, wandering rogue planets, sailing silently through the dark.
Which kind of brings us to our final provocative thought for today's explainer. We are incredibly lucky to be anchored by our star today, bathed in its warmth and its light. But the next time you look up at the night sky, you really have to wonder, just how many frozen lone planets are already out there, silently sailing through the vast emptiness of the dark? It is a chilling reminder of how fragile our existence really is. Stay curious, and we'll catch you in the next explainer.